Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Razi Imran bin Kamrul Azman. My metric number is A203514. So today I would like to explain about my final assessment assignment. So for question number 1, an unknown circuit with figure 1 with an input voltage supply gives an output voltage shown in figure 2. So this is the output, the graph. We have V input up here and V output up here. So the question asks us to propose a circuit with drawing that yield the result in figure 2. So for my case, I have to do it with resistor inductor since my metric number ending with even number. So with its proper value, support your answer with calculations. So first of all, go to the Ltspice. And first of all, the most important thing, we must have the voltage. So I click at the component, I pick voltage, I put it here. And then I have to use the resistor. I click on the resistor. I want it to be in horizontal, so I click it there. Next, I would like to have the inductor. I put it here. I click inductor, I put it here. And don't forget to have your ground. So because every complete circuit must have their own ground, which is 0 voltage. So after put all the components in the correct place, we have to connect it with the wire. So I pick wire and I connect all the components here right there. Make sure to connect the ground to sorry. Here. Alright, we connect the ground. After that, we fill up the value. So for voltage, I will use the sine voltage. So for amplitude, we have 5 volt. Frequency, I put 8 hertz. And for the phi or degree, I put 90 degree. So it will look like this. Next, I would like to enter the value of the resistor. I put 1 kilo ohm or 1000 ohm. I put right there. And for inductor, I use 15 Henry. Okay, once we have a complete circuit, we have to identify the V in and V out first. So I put V in. I click right here for V in. So for V out, I put it right here. So for V out. So we have the complete circuit. So once we have the complete circuit with all the values filled in, we can try to run or stimulate the circuit. So for the stop time, we have to refer to the question. So 0 until 250 millisecond. So I put it stop time 250 millisecond. Okay. So we got like this. Alright. So we want to stimulate the circuit or start to run the circuit. So we click right here. And then we see the amplitude of the graph started to the amplitude of the graph started to run on the screen. And then we also click at the V output, so we can get the type of graph, this type of graph. Yes, like this. Okay. So for the calculation, for the calculation, we know that VT is equal to V in equals also equals to IR plus V out. So for VL is equal to V out. It also equals to I times J omega L because of the ZL. So V in we have 5 volt with 90 degree. So for omega we have 2 pi f. Omega equals to 2 pi f. So we get 16 pi rad per second. So in order to calculate V in or V out, we have to calculate the Z total first. So Z total is equal to ZR plus ZL, which is equal to J omega L. So we got 1252.39 with 0.65 degree. So make sure our calculator is in the radian mode. So once we got this, we can calculate the current that flow through the circuit. So current equals to V source over Z total. So I get 4 exponent negative 3 or 4 milli with degree 1 of 1.39 degree. So for the V total, which is equal to V in, I got 5.1 volt, 2.04 degree. For V out, I got 3.02 volt, 2.96 degree. So for the phase shift, I got tangent. I got 0.64 degree. How I do it? I put negative tangent or shift tangent times with omega L over R.
Assalamualaikum. So continue with question number 2. Question number 2. An under-aggressive filter gives a frequency response, gain and phase shift shown in figure 3. The value of FL, FC and FH is 1 kHz, 5 kHz and 10 kHz respectively. So this is the figure. Question number 1. Propose a circuit withdrawing that is the result in figure 3. For my case, metric number ending with equal number, I have to use the resistor and capacitor. So we open the Ltspice. First of all, the most important component is the voltage. So we put voltage here. After that, we put resistor here. First resistor 1 and capacitor 1 here with parallel. After that, we go with capacitor number 2 and make sure we ground at the bottom to have a complete circuit. After that, we use the wire to connect all the components starting from here, up here until here. Okay. Then I assume the first resistor is 1 kilo ohm. The second resistor is 3 kilo ohm. The first capacitor I use 0.156 microfarad and second capacitor I use 5.3 nanofarad. And for this type of question, we don't have to put a value for the voltage because it is a band pass filter. Next, we go to the stimulate and edit stimulation command. We don't use transient, we use AC analysis. So for the type of sweep, we use decade. Number of points per decade, we use 10,000. Start frequency is 1 and stop frequency is 100,000 K. Then after that, after we have arranged and put our component in the right place, we started to test the circuit. So when we run the circuit, we touch at the input voltage and then for the output voltage. So you can get like this graph. So if you can see in here, this is the the gain, which is the V in over V out, and the bottom here is the phase shift, like this. So this is what you can get from the circuit. Sorry, gain V out over V in. So we can get like this. This is for the gain, and this is for the phase shifter. Okay, next, what about the calculation? Okay, first of all, based on the uh, circuit we have, we can conclude that the circuit is stop filter. It is obtained by low pass and high pass filters when they are connected in parallel. Okay, so uh, in order to prove that our value of first and second capacitor, use this calculation. So FV equals to 1 kilohertz, FH equals to 10 kilohertz, FC equals to C kilohertz. So we do the simultaneous equation. For R1 C1 we got 0.0015. So R2 C2 we got 1.59 exponent negative 5. So by assuming the resistor is 1 kilo ohm and the second resistor is 3 kilo ohm, we can get the final answer capacitor. First capacitor is 0.159 microfarad and the second capacitor is 5.3 nanofarad, which is the same answer as we got just now. So I think that's all from me. Thank you very much.